welcome back. So here we are, we're in the third video, and these should be consistently getting shorter and shorter as I go through them in this module. So hopefully this one will be shorter than the last one, which was shorter than the first one. Now, I've got you a link here to different libraries, the most popular libraries when it comes to Python. Before I open that up and have it pop up in a different frame or a different tab, what a library is. All right. Now, one of Python's prominent claims is that it's got the batteries included. We've got everything that you need. We've got this huge library of all these modules you need. Wait a minute. A library of modules. What's the difference between a library and what were we just dealing with? A package. Package? Library? Are they the same? Are they different? They're different. They both have modules in them, but packages are far more comprehensive. We install packages. When we install, I shouldn't say we install packages, we install libraries. We point to packages. So packages, if we think back to how we described them before, they're like folders or directories. And it could be a folder and a subfolder in our local folder, what we're dealing with, where our program is. But a library is usually far larger and more comprehensive. It comes along with documentation and all kinds of stuff. And Python comes with this standard built-in library. And I pointed to it up at the very top, above the first recording that I did. I think in the last video I went through it, looked at different stuff, and they're pointing at different modules in the Python standard library. Now, that's what comes built in. Well, if we think about it, think about your phone, for example. When you buy your phone, it comes with all the goodies that came with it. Whether you're dealing with an iPhone or an Android, whatever, it comes with stuff built in. And then we've got that App Store. Whether it's an Apple app or whatever app store we want to deal with. We've got a place to go get add-ons that do more than just the basic model. And that's where we're going now with this. That's where we're going now with this. And this is top 10 Python libraries you must know. Everybody's trying to sell me everything on here. Top 10 Python libraries you must know in 2022. So somebody's gone and posted this, and this is their opinion on what the top 10 are. Now, what we see here, there's TensorFlow, scikit-learn, NumPy, Keras, PyTorch. Now, these are libraries associated with machine learning or deep learning, or I should say AI. These are different tools where somebody has gone and created something to perform a specific task, but it's not one narrow task. It could be very comprehensive. Now, NumPy. I talked about NumPy before. I'm going to talk about NumPy here in a little bit. But rather than talking about NumPy now when we're in here, let me see, do I want Pandas or TensorFlow? Let's go look at, get this out of the way, Pandas. What is Pandas? Pandas is a machine learning library in Python that provides data structures of high level and a wide variety of tools for analysis. Data structures. We dealt with data structures. That was a few modules back. What was the data structure? Well, it's a way for me to have these logical groupings of data in specific data types, or it could be in a variety of data types. So this allows us to group data together in like tables or matrices, whatever it may be, to manipulate or analyze the data using some program. That's the kind of thing that takes place when these algorithms try to sell you stuff, whatever popped up at the bottom of the screen, those kind of things. That's what's taking place. Somebody's using something to aggregate our data that they've collected about us to do something. Now that's Pandas. That's a library. We've got date time. Now, date time's a module. It's not a library. It's in our built-in Python libraries. It comes built in. We saw it when I pulled up the standard library in the last video. Now here's a link to it. Here's some other documentation, different Python links to stuff that you can get. Go do additional reading if you choose to. Now I brought up date time early in the course, and I like to give opportunities to go get bonus points that go above and beyond what I've talked about in the course. I want you to go out, and not that date time is complex or hard to use. There's plenty of resources to go out and find out. That guy talked about date time. Let me find out about date time. Well, if you went and Googled it, you'd find what you see right here. A date in Python is not a data type all its own. It's getting information from your system and finding out what now is and formatting things as a date. And I can import date time that will interact with my system and tell me what now is. Year, month, day, hour, minute, second. Oh man, we're really getting deep in there. Microseconds. So this goes and looks at your system clock and finds out what now is. And then went and printed out what now was. Now, that's cool. What would I need that for? Well, in that example we had before, or I shouldn't say example, in the bonus points opportunity you had back in one of the early notebooks, you were able to use the date time module to find out what today's date is, and then add years to it. So I can go get the year, add a specific number to that year's. Oh, wait a minute. So if the guy said he was 27, he retires at 64, 64 minus 27, that's how many years he's got. Let me go get what year is it right now and add that to it, and that's the year that he retires. Wow. So it doesn't matter. I don't put a fixed number in there. If they run this program this year or 20 years from now, it'll still get the current year and the value will be accurate. That's why we would go use something like this. This is what we call modular programming. Breaking the work down into little outsourcing units, if you will. Now, I'm not going to have you go create your own module because of how I've gone about doing this. You know, like I said, Python uses modules. Colab, yeah, not so nice with modules. All right, so we can format what's being returned in a certain way. I want the year. I may want the day. I whatever it may be, and it'll go figure these things out for us as we run the code. Every time we run it, it will update, getting the most current information. So you may see this again in the next graded notebook. You may see the exact same task that you had before, but instead of it being bonus points, now you have to use date time to perform that task. Not only do we have date time that we can play with that's built in, we've got math, and we've dealt with that before as well. There's a min function, a max function built into that math module. Absolute gets rid of the negative. Pow returns something to the power of. Now, there's other ways to write this in Python. There's a pow function that's in the math module. I'm going to add something in here. And I'm going to use this same thing. And instead of pow, I'm going to do this way. X equals 4 to the power of 3. Now, when I run this, it says 64, using the power function, or the pow function. What if I did it explicitly? Same thing. There's code that somebody's written to perform a task. I may not want to have to deal with all that. I'll just write it out manually, which is, I think, less typing than what's there. But I could have put a variable in either one of them, so there's so many different things that I could have done, but essentially they do the same thing. So that's in the math module. All right, the math module is built in. Import math, we've got square root, we've got a ceiling, which is what's the lowest, or the highest number, the lowest number. Tell me what pi is. Now, once I've imported this, let's go see what happens here. It looks like it went sideways on me a little bit. So if I go this way, math.py, well, can I say just pi? No, I can't be implicit. What if I said I'm going to import math as Hootie? What's it going to do? It did the same thing. Since I imported it, and I'm explicit, it knows. So there's things I can get away with and things I may not be able to get away with. We've got another thing, and let's jump from modules to libraries. I know a little bit longer than the previous video, but this is all stuff that we've talked about in the past. I'm just going back over a lot of stuff. So in NumPy, why NumPy? So we can have an array. Arrays don't exist in Python, but there's this NumPy library that's got tons of modules in it that allows us to do things that otherwise we wouldn't be able to do. It's working with arrays, short for numerical Python. Right? Import NumPy as NP. NP is an alias. Most commonly used alias in Python, at least in my eyes. There's a lot of them that you'll see over time where people use the same aliases to refer to an instance of whatever that specific library may be. Right? Now, Python has strings, integers, floats, booleans, and complex numbers as data types, basic data types, whereas when we're talking about numbers or a boolean. But when we're talking about and numbers as well as strings, but when we're talking about NumPy's got a whole lot more. All right, we can create objects, time delta, complex floats, unsigned integers, booleans, integers. Man, there's a lot of stuff in there. And a lot of it has to do with the amount of memory being used for whatever it may be, or just more complex types of data. Here's some blocks of code that walk through the different ones. We're creating an array based on a list. Tell me what is the data type of that array. There's int 64, 64-bit integers in it. What is in there? U6 is the data type for these strings. So we've got different things that we're pointing to, whatever it may be, as the different data types. Think about in Python, the library, the function we used or the method we used was type. This one is dtype. It's doing the same thing, but dtype is in NumPy and type is in the built-in library. I can get the shape of an array, and that's essentially how big is it or how many items are in the different dimensions. Okay. Remember I said something relative to random. There's a random in NumPy. There's a random in the built-in. There's a random in math. There's randoms all over when it comes to Python. So remember I said be careful because you may have more than one thing with the same name. So NumPy random, math random. Why do we need to worry about the different ones? They may not all have the same functionality. One may receive more arguments and be able to handle different types of arguments. The other may not. Okay? So I'm going to go ahead and end this video, and I'll see you in the last one where I talk about additional concepts, and that's where we're going to change how we think about how we lay our code out.